Let's learn about inheritance in Java, a very powerful and important concept. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. If you noticed in previous videos, when we were working with Dragon and Human, we were doing the same thing over and over. Now, think about it. We have vampires. We need to do the same thing. We may have ogres. We have to do the same thing. We have ships or I don't know, any other type of creature that will have age, health, strength, and maybe names. Do we want to retype this constructor over and over with the properties being added over and over? Hell no. And you notice something? Because I was just rushing the video forward, I ignored this problem, this warning that says, hey, properties can become final. When you are doing a repetitive job over and over, the more you repeat yourself, the bigger the chance of having errors or warnings being ignored. Inheritance basically means that attributes and methods of one class can be inherited by another class. Basically, we will have a superclass that we call them parent that can have as many subclasses that we call children. If we want to make this happen in our base info, let's create a class, call it creature. Now creatures will have a property, but this time we make sure that we are doing it properly. Creatures will have a constructor that accepts name blah blah blah. So we say public creature that. And what are you yelling at me? Is assigned but never accessed, because we need to give the accessor, and this is the accessor. Always pay attention to these warnings because you may forget to do something and these are guiding you. Okay, this is the base creature class, just a boilerplate. However, now we can say dragons are type of creatures. So we simply say dragons are extending creatures from base info. And by the way, the import came out. And finally, we can't do the constructor this way. How can we call a constructor and we don't need the properties anymore? Because they are coming, and the method, because they are all coming from the creature. We just need a constructor. Now that we want to construct dragon, we have few different options. The first one is to have a parameterless constructor, because remember, creature doesn't have one. By default, it has something behind the scenes. But if we take a look at the hint here, it says there is no default constructor in base info creature. Okay, let's add one here. We call public creature. This is the parameterless. Now we want to somehow assign some default values to ourselves. We can call this with parentheses and say creature with the age of 1, health of 1, strength of 1. Basically, what we did here is we called our own constructor with some default values. Now, if we go back, the problem is gone. However, now I want to somehow change those values. So I will call super constructor, but I will say it's a dragon with the default age of at least 100, with the default health of at least 1000, and at least 1000 strength. This means that, hey, go back to your super class, being creature, call this constructor, assign the values for the dragon as a subclass. Basically, we are using the constructor of the superclass in the subclass. In other words, we are using what we inherited from our parent as our own. But here we are indicating that, hey, this was inherited from parent, so it's super. Super means that anything that related to the parent and we are inherited from. Normally, they are constructors. Okay, now as you see, I don't have anything else in this class. However, if I go back to main, dragon doesn't have this constructor and it gives you an error. It says that create constructor. we need to create this constructor for ourselves using tab keys here. And this is the name. I should have typed the age, health, and strength. And again, I just call this super, but with the constructors that we have. So it's name, blah, blah, blah. However, take a look. Our constructor was public. So why did we have to retype it? This is the difference between Java and C#. In C#, when you are inheriting from a parent, you don't need to retype this constructor with calling to this super. All you have to do is just inherit. However, in Java, you have to inherit and recreate your constructors calling super. The reason is that, for example, here maybe we have something different. I don't know, you name it. Let's put a string here and we call it effect. And in both cases, effect is not related to the creature. It only belongs to the dragon, not other creatures. So this is an attribute dedicated to dragon. Age, name, health, and strength are attributes that we inherit from creature. So here, for example, we say effect equals to nothing. Here we say effect equals to something. Doing this way of inheritance will let us avoid all this call in here that creates properties and characters and everything else. We don't have to say this properties equals blah inside Dragon. This super call is basically doing it. Let's put a breakpoint here and use debug mode this time, because I want to show you how the flow of logic is going on. It says that, okay, we want to create a dragon. You put a breakpoint here. We stopped here. Now we say go into. You see that it jumped into the dragon class, called this constructor, and stopped on this line. Again, go into. Oh, wait. We jumped to the creature and the constructor, and then we are assigning the properties. Okay, we are closing out of the creature. We go back into the dragon constructor. We assign the effect, and we come back to the program, and finally we move forward. This is how the inheritance works. Of course, if I print the value right now, the value is actually 1 million because we gave it a 1 million. This was dragon. Let's go back to human. We can say human extends creatures. And just by doing that, again, we are getting rid of these properties. We are getting rid of this initialization of properties here. And instead of creating properties, we call super with the name of human, one, health, blah. And we have this constructor, and instead of all of that, we call super. We don't need the access of properties. Now we have Joe and Alice as two humans being created by our main calling the register. And also we are inheriting from our parent. We are adding some inventory to this player, to these characters, and we are having a helper method that we can use for all humans. Now, funny enough, vampires can extend human. Why not? And we can hit Alt Insert, Constructor, and we choose both of them. Hit OK. And here we call the super with the default name of vampire. And let's say vampires have very long age time. I don't know, 10 times the health of a human and 500 strength. Now, I can simply delete all of these and say a vampire, and we call it vampire, equals to new vampire the killer. With the age of 1 million, he is very old vampire, health of 5,000, and the strength of 10,000. Before taking a look at the order of logic, we need to do something. So we say system.out.println. Now we go into vampire.properties.name. We put a breakpoint on this vampire and we go into the debug mode. Now we can use this arrow down to jump in. Take a look. It first jumped into this static block, assigning a value to the inventory count, then comes back, then goes to the constructor of vampire. Wait, why did it go back to the static on human? Because that was the first call on everything. It's static. Vampires are inheriting from human. The moment they are inheriting from human, they should call that a static name. Okay, we went into the constructor of vampire, then we go into the constructor of human. Human is extending the creature, you guessed it. We go into the constructor of creature, we assign the properties, we come back up to human constructor, we go back up to the constructor of vampire, we go back up from all the constructors back to our main menu, and then we print everything and the program is finished and we get the killer name. And this is a good example on how object-oriented programming puts pieces of puzzles together to make sure that everything is working properly without making your code very big. For example, for vampires, if we were not extending from humans, we had to add this guy. And if humans were not extending creatures, we had to add this, all of that. By using object-oriented programming, first, we made properties that encapsulates lots of logic by itself, and just one single line of code for definition, one single for getting them, and one single line for initializing those properties uses that encapsulation, makes the creature, and then by extending from creature, we made humans and dragons. By extending from humans, now we made vampires. This is the beauty of object-oriented programming. Are we finished? No. The most powerful part of object-oriented programming is coming in the next video called polymorphism. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.